Start at the very beginning. What exactly is a microprocessor? At its core, a microprocessor is the central unit of a computer system that performs most of the processing inside a computer. Think of it as the brain of your device, handling instructions, calculations, and data movement. Without microprocessors, modern electronics wouldn't be possible. They're found in everything from laptops and smartphones to cars and even household appliances. As we dive deeper, you'll see how this tiny chip powers the digital world around us. Story of the microprocessor begins in the early 1970s. Before microprocessors, computers were massive machines made up of many separate components. In 1971, Intel introduced the first commercially available microprocessor, the Intel 4004. This tiny chip revolutionized computing by integrating all the essential functions of a computer's central processing unit onto a single piece of silicon. Over the years, microprocessors have become smaller, faster, and more powerful, shaping the evolution of technology as we know it. How does a microprocessor actually work? At a basic level, it receives instructions from computer programs, processes them, and sends out the results. It does this by using millions or even billions of tiny electronic switches called transistors. These transistors work together to perform calculations, make decisions, and manage data flow. The microprocessor operates at incredible speeds, measured in gigahertz, allowing your devices to run smoothly and efficiently. Let's take a closer look inside a microprocessor. It's made up of several key parts: the arithmetic logic unit ALU, which handles mathematical operations, the control unit, which directs the flow of data, and registers, which store temporary data. All these components work together seamlessly, allowing the microprocessor to execute complex instructions in a fraction of a second. This intricate design is what makes modern computing possible. Transistors are the fundamental building blocks of microprocessors. These tiny switches control the flow of electricity, allowing the microprocessor to perform calculations and make decisions. Modern microprocessors contain billions of transistors packed into a space no larger than a fingernail. The more transistors a chip has, the more powerful and efficient it becomes. Advances in transistor technology have driven the rapid progress of computing power over the past decade. You may have heard of Moore's Law, a famous observation in the world of microprocessors. In 1965, Gordon Moore predicted that the number of transistors on a chip would double about every 2 years, leading to exponential growth in computing power. For decades, this prediction held true, driving innovation and making devices faster and more affordable. While the pace has slowed in recent years, Moore's Law remains a guiding principle in the semiconductor industry. It's easy to confuse microprocessors with microcontrollers, but they serve different purposes. Microprocessors are designed for general-purpose computing, like running your laptop or smartphone. Microcontrollers, on the other hand, are specialized chips used in embedded systems, such as washing machines or microwave ovens. While both contain a CPU, microcontrollers often include additional components like memory and input-output ports on the same chip. Central Processing Unit, or CPU, is the heart of the microprocessor. It interprets and executes instructions, manages data, and coordinates the activities of other hardware components. The CPU's speed and efficiency are crucial for overall system performance. As microprocessors have evolved, CPUs have become more powerful, enabling devices to handle increasingly complex tasks with ease. Clock speed, measured in hertz, determines how fast a microprocessor can execute instructions. A higher clock speed means the chip can process more instructions per second, resulting in faster performance. However, clock speed isn't the only factor that affects performance. Other elements, like the number of cores and architecture, also play important roles. Understanding clock speed helps you compare different microprocessors and choose the right one for your need. Modern microprocessors often contain multiple cores, which are essentially independent processing units within a single chip. Multicore processors can handle several tasks at once, improving multitasking and overall performance. For example, a quad-core processor can run 4 processes simultaneously, making it ideal for demanding applications like gaming or video editing. The rise of multicore technology has transformed the way we use computers and mobile devices. Microprocessors use instruction sets to communicate with software. An instruction set is a collection of commands that the processor can execute, such as adding numbers or moving data. Different processors may use different instruction sets, like x86 or ARM. The choice of instruction set affects compatibility, performance, and power consumption. Understanding instruction sets is key to appreciating how software and hardware work together. Cache memory is a small, high-speed memory located inside the microprocessor. It stores frequently used data and instructions, allowing the CPU to access them quickly without waiting for slower main memory. The presence of cache significantly boosts performance, especially during repetitive tasks. Modern microprocessors often have multiple levels of cache, each serving a specific purpose in the memory hierarchy. Microprocessor communicates with other components through a system of buses. These buses are electrical pathways that transfer data, instructions, and power between the processor, memory, and peripherals. The speed and width of the bus system directly impact the overall performance of a computer. As technology has advanced, bus systems have become faster and more efficient, supporting the demands of modern computing. Fabrication process of microprocessors is a marvel of modern engineering. Chips are made from silicon wafers, which are sliced, etched, and layered with microscopic circuits. This process requires extreme precision in clean environments, as even a tiny speck of dust can ruin a chip. Advances in fabrication have allowed manufacturers to pack more transistors into smaller spaces, driving the miniaturization of electronics. Power consumption is a critical factor in microprocessor design. Efficient chips use less energy, generate less heat, and extend battery life in portable devices. Engineers constantly strive to balance performance and power using techniques like dynamic voltage scaling and sleep modes. As devices become more compact and powerful, managing power consumption remains a top priority. As microprocessors work harder and faster, they generate more heat. Effective heat management is essential to prevent overheating and ensure reliable operation. Techniques like heat sinks, fans, and thermal paste help dissipate heat away from the chip. In high-performance systems, liquid cooling may be used. Keeping microprocessors cool is vital for maintaining performance and extending their lifespan. Microprocessors are everywhere in our daily lives. They power smartphones, laptops, cars, appliances, and even smart home devices. From managing your morning alarm to controlling your car's engine, microprocessors make modern conveniences possible. Their versatility and reliability have made them an essential part of the digital age, quietly working behind the scenes to keep our world running smoothly. The world of gaming and graphics, microprocessors play a crucial role. High-performance CPUs and specialized graphics processing units, GPUs, work together to deliver stunning visuals and smooth gameplay. As games become more complex, the demand for powerful microprocessors continues to grow. Whether you're a casual gamer or a professional, the chip inside your device is working hard to create an immersive experience. Smartphones and tablets rely on advanced microprocessors to deliver fast, responsive performance. These chips are optimized for low power consumption and high efficiency, enabling all-day battery life and seamless multitasking. Mobile microprocessors often integrate additional features like graphics, connectivity, and security, making them true all-in-one solutions for portable devices. Modern vehicles are packed with microprocessors that control everything from engine performance to entertainment systems. Advanced driver assistance features, navigation, and connectivity all rely on powerful chips. As cars become smarter and more autonomous, the role of microprocessors in the automotive industry will only continue to grow, paving the way for safer and more efficient transportation. Microprocessors are revolutionizing healthcare by powering medical devices, diagnostic equipment, and wearable technology. From monitoring vital signs to assisting in complex surgeries, these chips enable faster, more accurate care. As technology advances, microprocessors will continue to play a vital role in improving patient outcomes and transforming the medical field. Factories and industrial systems depend on microprocessors for automation, control, and monitoring. These chips manage robotic arms, assembly lines, and quality control systems, boosting productivity and efficiency. As industries embrace smart manufacturing and the Internet of Things, microprocessors will be at the heart of the next industrial revolution. Internet of Things connects everyday objects to the Internet, and microprocessors make it all possible. From smart thermostats to connected refrigerators, these chips enable devices to collect, process, and share data. As IoT continues to expand, microprocessors will play an even greater role in creating intelligent, interconnected environments. Artificial intelligence relies on powerful microprocessors to process vast amounts of data and run complex algorithms. Specialized chips like AI accelerators are designed to handle machine learning tasks efficiently. As AI becomes more integrated into our lives, the demand for advanced microprocessors will continue to rise, driving innovation in both hardware and software. Security is a top priority in microprocessor design. Modern chips include features like encryption, secure boot, and hardware-based authentication to protect data and prevent unauthorized access. As cyber threats evolve, microprocessors must stay ahead with robust security measures, ensuring the safety and privacy of users and organizations. Energy efficiency is more important than ever, especially in portable and battery-powered devices. Microprocessor designers use advanced techniques to reduce power consumption without sacrificing performance. Features like low-power states, dynamic voltage adjustment, and efficient architectures help extend battery life and reduce environmental impact. Overclocking is the practice of running a microprocessor at a higher speed than its official rating. Enthusiasts use this technique to boost performance, especially for gaming or demanding applications. However, overclocking can increase heat and power consumption, so it requires careful monitoring and cooling solutions. While it offers benefits, it also comes with risks and should be done responsibly. Microprocessors work closely with chipsets and motherboards, which connect and manage all the components in a computer. The chipset determines compatibility, features, and expansion options, while the motherboard provides the physical platform. Choosing the right combination ensures optimal performance and future upgradability. Future of microprocessors is bright, with exciting developments on the horizon. Researchers are exploring new materials, architectures, and manufacturing techniques to push the limits of performance and efficiency. Technologies like quantum computing and neuromorphic chips promise to revolutionize the way we process information, opening up new possibilities for science, industry, and everyday life. Despite remarkable progress, microprocessor development faces significant challenges. Physical limits, heat dissipation, and rising costs make it harder to keep up with Moore's law. Security threats and supply chain issues also pose risks. Overcoming these obstacles will require innovation, collaboration, and new approaches to chip design and manufacturing. Microprocessors are built using different architectures, with RISC, Reduced Instruction Set Computer, and CISC, Complex Instruction Set Computer, being the most common. RISC chips use a simplified set of instructions for faster execution, while CISC chips offer more complex instructions for versatility. Each approach has its strengths and is suited to different applications, from mobile devices to servers. Embedded systems are specialized computers built into other devices, and microprocessors are at their core. These systems control everything from washing machines to traffic lights, performing dedicated tasks with high reliability. Embedded microprocessors are designed for efficiency, low power consumption, and real-time operation, making them ideal for countless applications. Build programmable gate arrays, FPGAs, and custom chips offer flexibility and performance for specialized applications. FPGAs can be reprogrammed after manufacturing, making them ideal for prototyping and research. Custom chips or ASICs are tailored for specific tasks, delivering maximum efficiency. Both play important roles alongside traditional microprocessors in today's technology landscape. Cloud computing relies on powerful microprocessors in data centers to deliver services over the internet. These chips handle massive workloads from streaming video to running business applications. As more services move to the cloud, the demand for high-performance, energy-efficient microprocessors continues to grow, shaping the future of digital infrastructure. Supercomputers are the giants of the computing world, using thousands of microprocessors working in parallel to solve complex problems. These machines tackle tasks like climate modeling, scientific research, and cryptography. Advances in microprocessor technology have enabled supercomputers to reach unprecedented speeds, pushing the boundaries of what's possible in science and engineering. Wearable devices like smartwatches and fitness trackers rely on microprocessors for their intelligence and connectivity. These chips enable features like health monitoring, notifications, and wireless communication. As wearables become more advanced, microprocessors will continue to drive innovation in personal technology and health. Smart home devices, from voice assistants to security cameras, are powered by microprocessors. These chips enable automation, remote control, and intelligent features that make homes more convenient and secure. As smart home technology evolves, microprocessors will remain at the heart of connected living. Microprocessors are transforming education by powering digital classrooms, e-learning platforms, and interactive tools. Students and teachers benefit from fast, reliable devices that support collaboration and creativity. As technology becomes more integrated into education, microprocessors will continue to shape the future of learning. Space missions rely on robust microprocessors to control spacecraft, analyze data, and ensure mission success. These chips must withstand extreme conditions and operate reliably for years. Advances in microprocessor technology have enabled more ambitious missions, from Mars rovers to deep space probes, expanding our understanding of the universe. Robots depend on microprocessors for intelligence, control, and adaptability. From industrial robots on factory floors to personal assistants at home, these chips enable machines to sense, think, and act. As robotics technology advances, microprocessors will play an even greater role in shaping the future of automation and artificial intelligence. Banking and finance industry relies on microprocessors for secure transactions, data processing, and fraud detection. High-speed chips enable real-time trading, online banking, and mobile payments. As financial technology evolves, microprocessors will continue to drive innovation and security in the digital economy. Microprocessors are used in environmental monitoring systems to collect and analyze data on air quality, weather, and pollution. These chips enable real-time tracking and help scientists make informed decisions to protect the planet. As environmental challenges grow, microprocessors will play a key role in sustainability efforts. From smart TVs to digital cameras, microprocessors are at the heart of consumer electronics. These chips enable advanced features, connectivity, and user-friendly interfaces. As devices become smarter and more integrated, microprocessors will continue to enhance our digital experiences at home and on the go. Protecting data is more important than ever, and microprocessors play a crucial role in security and privacy. Hardware-based encryption, secure storage, and trusted execution environments help safeguard sensitive information. As cyber threats evolve, microprocessors will continue to be the first line of defense for personal and organizational data. Summary: microprocessors are the invisible engines driving the digital world. From powering everyday devices to enabling cutting-edge research, their impact is everywhere. As technology continues to advance, microprocessors will remain at the forefront of innovation, shaping the future in ways we can only imagine. Whether you're a tech enthusiast or just curious, understanding microprocessors gives you a glimpse into the heart of modern technology.